Cleavage of covalent bond. A covalent bond can undergo cleavage or fission in two ways. Homolytic cleavage, second heterolytic cleavage. The covalent bond comprises two electrons. Bond pairs of electrons shared between the two bonded atoms. In homolytic cleavage of a covalent bond, one of the two electrons goes to one of the bonded atoms and the other is bound to the other. Movement of a single electron is represented by a half-headed curved arrows or first hooks. The tail of the curved arrow indicates the place from where the electron is removed, while the head of the curved arrow indicates the place where the electron reaches as a result of the movement. Such homolytic cleavage of a covalent bond give rise to two neutral species carrying one unpaired electron each. A species with single unpaired electron is called free radicals or sometimes just radical. A free radical is unstable and thereby a reactive species having a tendency to seek an electron for pairing. A homolytic cleavage thus is represented as A, B under radical reactions form into A radicals and B radicals. For example, CH3Cl methyl chloride after absorbing light turns into CH3 dot as methyl radical, free radical, chlorine radical or chlorine atoms. Homolytic fusions is favored in the presence of ultraviolet radiations or suitable peroxide or at a high temperature. The organic reaction which processed by homolytic fusions are known as free radicals or non-polar reactions. Free radicals have only transitory existence. These are formed as reaction intermediate where subsequent react with another radicals or moment or molecule to restore. Stable bonding pair. A carbon-free radical is sp2 hybridized unravel, planar trigonal geometry. Shape of methyl free radical. Alkyl free radicals are classified as primary, secondary, and tertiary. The observed stability out of alkyl free radical is third butyl free radical greater than isopropyl free radical greater than ethyl free radical greater than methyl free radical. In heterolytic cleavage of covalent bond where shared electron go to one of the two bonded atoms. This turn out to be the more electronegative atom of the two. Movement of an electron pair is represented by a curved arrow. Heterolytic cleavage of covalent bond give rise to two charged species, one with negative charge and other with positive charge. The negative charge anionic species has the more electronegative atoms, which has taken away the shared pair of electron with it. A heterolytic cleavage is represented as A, B after bond breakage turns into A plus cation, B minus anion as product. B is more electronegative than A, that's why B is formed as anion. Methyl bromide after bond breakage transfer electron into bromine turns into CH3 plus methyl carbocation bromide Br minus. Bromine is more electronegative than carbon. Heterolysis is favored in polar solvent. In methyl bromide, bromine is more electronegative. This heterolysis of methyl bromide results in formation of methyl carbocation and bromide anion. carbon atoms have sextet of electrons and positive charge is known as carbocation. Earlier called carbonium ions, carbocation are highly unstable and receive and react to species form as intermediate in many organic reactions. PZ orbitals CH3 plus methyl shape of methyl carbocation. The central carbon atoms of a carbocation is sp2 hybrid states and has trigonal planar geometry. The pz atomic orbital is vacant and is perpendicular to the plane containing the 3 sigma bonds at the carbon. Carbocation are classified as primary, secondary, and tertiary. The observed stability of alkyl carbocation follow the order tertiary butyl carbocations greater than isopropyl carbocation greater than ethyl carbocation greater than methyl carbocation. Heterolytic bond fusions generate a species called carboanion, in which carbon gets to share pair of electron. This happens when a carbon atom is bonded to the electropositive atoms. CH3Z heterolysis gives CH3 minus plus Z plus. Z is more electropositive than carbons. The central carbon atom of carbanion has complete octet of electron and a negative charge. The carbon anion is unstable and reactive, which is formed as a reaction intermediate. Heterolytic fusions is favored in the polar solvent. The organic reaction proceeds through heterolytic fusions known as heteropolar or polar or ionic reaction. Most organic reactions take place in solution follow ionic mechanisms. Can you tell? Some bond fusions are described in the following table. For each of them, show the movement of electrons using curved arrow notations. Classify them as homolysis or heterolysis and identify the intermediate species produced as carbocation, carbanion, and free radical. CH3 copper after bond breakage turns into CH3 minus copper plus. Type of cleavage is heterolysis, intermediate is carbon anion.